this will be our third chapter where we'll be dealing with complete foundation of statistics. So basically, we'll be looking into various statistical models which will form the foundation well for any machine learning. Okay. Continue. So what exactly we'll be learning over here? So we'll be having we have descriptive statistics, we have probability and conditional probability, and we have the biggest problem of distribution. So that will be like the probability distributions. We concentrate on the main three, that is nothing but binomial, Poisson, and normal distribution. And last but not least, we'll be going with hypothesis testing. So we'll be having a lot of confidence with statistics. Okay, so in this particular video we'll be learning only about basic about statistics. We'll not get into again much technical, so we'll have a few of the just surface level touching with it. Okay, so again, what is exactly statistics? It is a practice or a science of collecting collecting and analyzing numerical data in large quantity, especially for the purpose of inferring proportions in code from those in a representative samples. Okay, so basically, what exactly is statistics? The practice of science of collecting and analyzing numeric data in large quantities, especially for the purpose of inferring proportions in a whole for those in a representative samples. Also, this is the same definition which I had given a minute ago, but basically here again this definition is telling with respect to large quantities and all. So I have a simpler one. So basically it is a branch of science that deals with numeric data. It is mainly used to infer knowledge about big sections, or like a part like knowledge about big sections, or maybe a part or a proportion, by trying to understand a smaller part of it. Take an example to understand this better. So we can say that there is a we say that all people in particular state can be called as a population. Okay, and therefore it can be a state or a country itself, and therefore the population for particular experiment for whatever purpose we will be taking a portion of it, or a small partition. So maybe you want to check some kind of condition with respect to how many people are working into IT sector in a probably an area, or you can consider a metropolitan city. Okay, so a metro city over there, maybe you can consider a IT hub over there. So over there definitely you will have a lot of population working with IT sector rather than other districts in a state. So if you consider randomly one of the states, whereas over there the number of members working in an IT would be very less. Okay, so again these states what I'm telling can be in case of country also. So there are few states in particular, like in a country, like I just want 10 or 20 people in each state to be considered. So maybe I want to check who is working at a very high level, like kind of managers, CEOs, something like that. So basically here what we are doing is we are taking samples from those populations, or you can take the entire country as a population itself, like various samples for various places, and then in turn will represent the entire population. Okay, so basically small samples, and then like basically various samples from various places will. So why do we need statistics? And I hope you have already got that. Why exactly we need statistics? But just we'll have a look at it. So the major reason is that it helps us to understand data better, and also we will understand the data better. We work on it better. So when we understand the data better, definitely we'll be working on it better, or when we work on it better, or our whatever deliveries or outcomes, or basically in machine learning we'll be having predictions, right? So after working on the data, turns out to be even better. So that means that means nothing but getting our accuracy or prediction or approximations correct with respect to the machine learning models. Okay, so that is talking about in perspective of use of statistics for machine learning, but rather going with just the perspective of statistics also, it will be helping us to understand data. It can be any form of data. Again, we'll be seeing examples in our upcoming videos, which will give us a better picture. But from then I'm speaking about data. So what kind of data do we deal with? So I've been telling the word data again and again for quite for some time, but I would like to explain in detail. So here, first thing is the data. Like first thing, what we need to understand is that data can be thrown up as we talk about unstructured data. Okay, so basically, it's basically something that it's way complicated to see visualization. Some examples is like audio files. They have like various length, various high pitches of various wavelengths and all. So maybe volume might be changing with respect to even left side, right side, or even if you are going with an Dolby or Atmos, then it will become much more complicated. So that's why it has various channels. And if I have to say it in a way that it is more or less it is like kind of true, and and there is various of factors which makes it difficult to just look at it and understand. Okay, so we can't just have data everywhere with respect to like kind of, as I was telling examples, unstructured data. Okay, so whereas on the other hand we have structured data, which is not that difficult. So this can be found in form of tables, which will be in terms of columns and rows. So in the Python demonstration in the pandas, we just imported in a data set, right? So it was like a dummy data set where we had some kind of 10 rows and 3 columns, if I'm not wrong. So that is something like table data. So that is the best example for any structured data. So which would be represented in an Excel sheet. And hoping everyone who has at least seen it once, we have already come across through. So the entire data over there is just a repetitive rows and columns, which makes it really easy to understand. So now there is divisions between data as well. So the first thing is that the singular form of data is actually called as datum. Okay, so here data is nothing but a plural form. So many people do not know this. Even I didn't know a few couple of years ago. So yeah, so there is a meta divisions of data between numerical and categorical. Okay, so I think we'll go ahead with understanding what exactly is numerical. So before that, we can say that how many legacy or basically numerical is nothing but it might be a questions like how many legs do you have? 2. How many hands do you have? Some 2. Maybe how many ears and how many nose, how many eyes and all. So whatever the outcome or the values you are getting, they're all so basically they are all numbers. So any data that you are going to represent in terms of numeric comments, so comes into this kind of division. So that is nothing but numeric or quantitative data. But when it comes to categorical or qualitative data, so basically we are talking about something which is more of fixtures. Okay, so it is not like a kind of numbers and all. Okay, so basically here we have an example. He is a clever boy. Okay, so you don't measure cleverness based on any scale or anything. So maybe you have a random vague scaling, but it is not represented with respect to number. So you might tell 2 boys are clever, and you are not sure which boy is exactly clever. Okay, so maybe like who is both can be clever, and you cannot gauge on who is more clever than the other guy. Okay, so there can be a few aspects and all, maybe with respect to their analytic skills or mathematical skills. Again, it varies. Okay, so that is how all such data will be coming under categorical data. Now again, with respect to numerical or quantitative data, we again have discrete data and continuous data. Okay, so basically discrete data will be like something like this data is directly countable. Okay, so you will be counting it. So basically to have a difference between discrete data and continuous data is just nothing but having a fractional part or the decimal part. So that would be a continuous data, whereas the discrete data is not that. So basically they are whole numbers. When it comes to discrete data, so basically how many children you have or how many students you have in your class or something like that. Okay, so all those will come under discrete data type. And continuous data type is something like measurable. Okay, so you can ask a person what is his height or probably weight, or if you are considering an object, you can consider like height, width, and length. Okay, so that is the major difference between the discrete data and with respect to the continuous data. So now again, with respect to categorical data, so again we have three major divisions over here. So what are they is like, currently you can tell, the first thing is binomial data, so variable data with only two options. Okay, so here basically you are telling whether it is right or no, or true or false, good or bad. Maybe you can consider one example which I would like to give is, maybe you have an application which you have deployed, maybe an Android app where it is running with respect to, maybe it is running on some system. Okay, probably an like Play Store you have released an Android app. Okay, so over there you will be getting a lot of reviews from the users. Okay, so forget about the stars. Okay, just with respect to reviews. So over there reviews, you can categorize them as whether it is a positive review and negative review. You literally have a data and you can categorize them. Okay, so basically here by binomial, so here it is like by means 2, so that's why we'll have only two options. Okay, so positive review and negative review. I think that is the best example which you can give with respect to binomial data. So again, having positive reviews, negative reviews, you can categorize and find out what exactly is the negative reviews impacting, which you should improvise, and what are the positive reviews and where are the aspects which you need to like again keep those features on, and also try to improve those features also. Okay, so that is how a machine learning expert or application will be using with respect to binomial data. And nominal data is nothing but unordered data. So basically here the data would be like it will be in unordered fashion. Okay, so maybe if I tell name any three of your favorite colors, you might go ahead and just tell the primary colors like red, blue, and green. Okay, so now if I tell just order them. Okay, so you might be like randomly ordering red, green, and white. So maybe red, green, and blue if you are ordering with respect to alphabets, so that becomes alphabets. Okay, that is the word which is representing the color rather than the color itself. Okay, so coming to the color aspect, like red, green, and blue, you can't order them, right? So the red doesn't has any kind of majority or something kind of significance over blue in any terms when you're speaking generalized. Okay, so maybe if you are distinguishing between their wavelengths and all, it definitely comes under binomial. But this is like random. Okay, so you will definitely have some such kind of data, especially in the real world when we are seeing real world examples. So nominal data or unordered data is like kind of common where you can come across. Okay, so that is with respect to nominal data, and the final type is nothing but the ordinary data. Okay, so the ordinary data is like basically variable data with proper ordered. Okay, so it's like short, medium, and long.